Hi everyone, thank you for joining me at this webinar. My name is XY and today I will be giving a brief presentation on immune dysfunction feature of COVID-19 patients and how some labs in China use immune monitoring for assessment on the disease. I would like to take this opportunity to thank my colleague Xianglan who has helped me with this presentation deck. First of all, we need to understand the role of our immune system. There are three main immunologic functions of our immune system. Immune defense, which involves defending against foreign particles or pathogens from the body. Immune surveillance, to detect and eliminate abnormal or mutated cells. And immune homeostasis, which modulates immune responses, toggling between tolerance and overreactivity, ensuring that there is appropriate level of response being initiated at the stimuli. When immune defense fails, we will be immunocompromised and thus have a higher risk of repeated infections. Overreactivity of an immune defense can also lead to cytokine storm, which we do see in some COVID-19 cases. In cases when the body fails to detect or eliminate abnormal and mutated cells, these cells are likely to proliferate and form tumors. Disruption of immune homeostasis can easily trigger autoimmune disease. These three main functions of our immune system form a tightly regulated network to ensure that we are well protected and to maintain our physiological condition. Have you wondered why some SARS-CoV-2 infected patients are symptomatic, whereas some are asymptomatic, and why some develop severe disease while some are mild or recover quickly? We have to look into two main underlying factors that contribute to the infection: the pathogen themselves and our immunologic function. We need to understand that after being exposed to the virus, it also takes time for the virus to proliferate and replicate. There is a need to reach a certain viral titer to cause symptoms, and depending on the original viral load a patient is exposed to, it can take days to weeks before one shows up with symptoms. Looking at the graph, infected patients with low level of viral load can remain asymptomatic, and patients with higher viral load will have a large risk of mortality. On the other hand, a person's immunity also plays an important role in the development of an infection. If we have a strong immune system, our body can react and fight to clear the virus, and the virus may take longer to proliferate and replicate. Someone with a weaker immune system will usually have problems defending against the virus and will show more serious symptoms or even develop complications. This is why the elderly and people with chronic disease are more susceptible to the infection. Flow cytometry is very useful in characterizing our immune cells that make up complicated network of our immune system, which involves innate and adaptive responses. The main cells that are involved in our immunity are the white blood cells, which include granulocytes, monocytes, and lymphocytes. Flow cytometry can provide information regarding these cell types and allow us to study the function of these cells. It is not uncommon in clinical labs to test for lymphocyte subsets. Within our lymphocytes, there are T cells, B cells, and NK cells, or in short, TBNK. Our T cells are involved in cell-mediated immune responses and can be further differentiated into two main subsets, namely the T helper cells expressing CD4 and T cytotoxic cells expressing CD8. In this presentation, I'll focus more on the involvement of lymphocyte subsets in an event of an infection. Looking at our CD8 T cytotoxic cells, they are one of the main executors of cellular immune response that are involved to fight against cells infected with viruses or intracellular bacteria. They can identify those infected cells and trigger cytotoxic effects to kill the cells. Our CD4 T helper cells are the most common T cells that hold a central role in our immune response. In an infection, CD4 T helper cells will differentiate into classes, producing different groups of cytokines and chemokines to facilitate an immune response. For example, they can secrete IL-4, which will help to activate B cells to differentiate into antibody-producing plasma cells. They can also act through interferon gamma or IL-2 to enhance killing effects to the pathogen. Due to the dynamic responses triggered by CD4 T helper cells, people with no or low CD4 T cells will have weak immunity or a more severe clinical outcome. An example of immune-compromised patients are people with AIDS, where the human immunodeficiency virus attacks the CD4 T cells. In these patients with AIDS, they have very low numbers of CD4 T helper cells and are unable to mount a response to any infection. We can further dive down into the functional aspects of T cells in an infection. Our T cells originated from the thymus as naive T cells expressing CD45RA, and they have low antigen specificity and limited fighting capabilities. Upon their first encounter with pathogen like a virus, they will expand and develop into effective T cells, which are the ones triggering the immune response. At the end of the immune response, most effector T cells die, but some will remain as memory T cells, which recognizes what they have been exposed to. These memory T cells retain the ability of rapid and more potent antigen-specific immune response when they are re-exposed to the same antigen. On the other hand, B cells are known to produce antibodies to destroy pathogen. The increase in B cells can be commonly seen in autoimmune disease or in an allergic reaction where excess immunoglobulins are being produced. In severe infection or under immunosuppressants, the number of B cells can be significantly reduced. In the fight against COVID-19, our B cells do produce antibodies in attempt to clear the virus. However, note that it takes time and requires strong T cells activations to produce enough antibodies to neutralize the viruses. Another group of lymphocytes in our body are the NK cells, or natural killer cells. They perform immunologic surveillance and are known to kill virus-infected cells to control early tumor growth. They act through their activating and inhibitory receptors, which allows them to recognize cell from non-cell. Unlike CD8 T cytotoxic cells, they don't require prior priming and activation to initiate killing. This is the reason why they are named natural killers. Due to their rapid response, we can observe an increase of these cells in early stage of an infection. Now that we know a little more on how TB NK cells are involved in an infection, let's now look at how some labs in China use immune monitoring to assess COVID-19 patients. In a recent study at Chongqing Sanxia Central Hospital, they segregated 123 COVID-19 patients into two groups: mild symptoms and severe symptoms. The proportion of patients with decreased CD4 T cells and CD8 T cells in the severe group is higher. We can see that 95.24% of patients have low CD4 counts in the severe group and 52.9% in the mild group. 61.9% have low CD8 counts in the severe group and 28.4% in the mild group. There was no significant difference in the proportion of patients with reduced B cells between two groups and a slight difference in the decrease in NK cells between two groups. This indicates that T cell responses are being suppressed in critical cases and worsening their condition, which may provide new insights and prognostic value for COVID-19. Another recent treatment plan from Peking Union Medical College Hospital, or PUMCH, suggested looking at how absolute counts of lymphocytes in COVID-19 patients. They mentioned that patients with high fever and low lymphocyte counts or substantial low CD4 and CD8 counts must be isolated and monitored, even if they present with normal lung imaging or negative SARS-CoV-2 tests. They are also recommended performing immunologic function assays of TB-NK subsets using 11 markers at diagnosis, and to continue to monitor on the 5th and 7th day. From these recommendations, we can see that due to the challenges faced in false negatives using molecular assays, as well as limited imaging capacity, the assessment of immune status can provide useful information for preliminary diagnosis. Past studies on influenza also shows that patients with CD4 and CD8 low counts have a higher risk of developing severe disease. It appears that COVID-19 patients are progressing the same way, although we still do not have enough data to support this conclusion. Nevertheless, if we can perform immune monitoring in clinical settings, it gives us an opportunity to detect such changes in our immune status and start early clinical intervention. This is the panel used by PUMCH, who did a dynamic assessment on the lymphocyte subsets looking not only at TB-NK cells, but also the level of naive T cells, memory T cells, and their level of activation. When our immunity is weakened by the virus, the body can easily acquire other infections and develop complications, which could lead to mortality. Another hospital at Shenzhen released their version of diagnosis and treatment plans for COVID-19 patients, which also include monitoring lymphocytes and T cell subset level. For severe and critical cases with significant reduction of lymphocytes and CD4 T cells, they will be given subcutaneous thermoflasin 1 to 2 times a day to modulate immune response. Studies have shown that a majority of COVID-19 patients require antibiotics, and a smaller percentage will even require antifungal treatment. These studies show that patients with severe disease are likely to develop complications. They recommend using intravenous immunoglobulins to boost the immune response in such patients. This again re-emphasizes the importance of our immunity in defending against infection. From what we have discussed, we understand that viral infection can potentially attack our immune cells, weakening our immunity. Monitoring TB-NK subset counts can help us determine if an infection has occurred, the level of severity which may lead to potential infection risk, as well as possible indicator of treatment efficacy. At Beckman Coulter, we have solutions that can support immune monitoring. We understand that labs doing COVID-19 research or work will require higher stringency in terms of safety and workflow effectiveness. With EchoCL, this is a fully automated load angle cytometer, which can help to monitor your lymphocytes and TB-NK levels. EchoCLs are inbuilt with sample prep system designed to minimize hazard exposure as they take in primary tubes directly without the need to open any of the blood tubes. They are compact and can be directly linked to LIS for reporting. If you would like to expand the immune monitoring panel, Beckman Coulter offers a wide range of reagents, including the single color antibodies and our dry reagents powered by Dual Innovation. Our dry reagents are a cocktail of various antibodies dried at the bottom of the tube. It can help to lower the risk of infection by reducing hands-on time and improving workflow effectiveness. We understand that the current research on COVID-19 focuses on T cells, which is also described by PUMCH. However, if you like to look at how other immune cells like granulocytes and macrophages can be involved in COVID-19, we can also offer custom design services to suit your need. Beckman Coulter also offers cytometers that are small and compact, suitable to be placed in BSC for infectious work. The automated sample prep systems helps to minimize sample contact and enhance safety to the operators. We are focused to creating safe and effective workflows from sample preparation to reporting. With our solution for immune monitoring, we hope to help scientists and clinicians in their battle against COVID-19. With that, thank you for your time, and I wish all of you good health and hope to see you soon.